Okay, given the function f of x equals to root of x, what is, for example, f prime of 4? Well, it is the limit as h goes to 0, f of 4 plus h minus f of 4 divided by h. And this is equal to the limit as h goes to 0. Now f of 4 plus h is root of 4 plus h minus f of 4, because you're taking root of 4, right? So this would be what? 2 divided by h. So you have to find the limit of this fraction. And how would you find the limit? Well, root functions, our trick for finding limits was what? Multiply and divide by the conjugate. So I could do this, and if I do that, then this is the limit as h goes to 0. When you multiply the two numerators, you're going to end up with 4 plus h minus 4, and the denominator would be, as it is, h times 4 plus h plus 2. Do not multiply out the denominators, and what you're going to get is that this is the limit as h goes to 0, h divided by h times root of 4 plus h plus 2. H cancels out, plug in 0, you get root of 4 plus 0 plus 2, and that is equal to what? 1 over 2 plus 2, right? Okay, just wanted to do an example of what I mean by finding the derivative by using the limit definition. So what we found then is that the derivative of the function root x at what was that, at 4 is equal to 1 over 4. So this is the what? This is the derivative with respect to x of the function root of x, right? And the derivative of this function evaluated at x equals to 4. And that's what we are saying is 1/4. If you want to make sure that you got the right answer, you can find the derivative of root x by using the formulas, and then evaluate the derivative at 4 and make sure you get the same answer. So is everybody okay? All right, so that's part A of question number 1. What would be part B of question number 1? This would be a limit problem from section 2.4. So find the limit as t goes to 0, for example, something like tangent of 6t over sine 2t. I think this is what you had in your quiz, right? Tangent of 6t or something like this. So this is a problem from section 2.4. It's a limit problem from there. And remember, the idea was to use the fact that limit of sine theta divided by theta is 1. So you have to use that limit in order to compute the limit of this fraction. Okay, so that's one question from 2.4. How would you do this problem? Well, I mean, you might have a different question than this one, but The idea, for example, here, how did you compute this in your quiz? Yeah, so you write tangent of 60 as sine 60 over cosine 6t, and then you also have that 1 over tangent of sine of 2t, and then we, I think, decided that we would write this as sine 60 over 1 times 1 over cosine 60 times 1 over sine 2t. And then in order to use the fact that the limit of sine theta over theta is 1, we need a 6t in the denominator here, we need a 2t in the numerator here. If I had 6t and 2t like this, I could have said that the limit of the first ratio is 1, limit of the third ratio is 1 as well. So by what factor did I change the expression? I changed the expression by a factor of 2t over 60, right? So we have to then multiply by what? 6t over 2t, which means basically what? 3/2, right? No, 3. Just 3. Okay. So we changed the entire expression by a factor of basically 1/3. So we are multiplying by 3 to make sure we didn't change the expression. So now I could say that the limit of this guy is 1, the limit of this guy is 1, and what's the limit of this guy? The limit of this guy is 1 because cosine, when t is 0, cosine 0 is 1. So altogether then the limit turns out to be 3. Okay? Okay, so that's 1b. So how about problem number 2? There will be, this is basically find derivatives and basically you're going to have part A here, part B here, part C here, and part D here. Part A question would be from section 2.3. So basically you'll be given a function and you have to find the derivative of that function. Remember, section 2.3 is about product rule and quotient rules, right? And then one derivative question from section 2.4. These are questions between 1 and 16, I think. And then there are 2 questions from 2.5. 2 questions from 2.5. 2.4 is the section on derivatives of trig functions, but you don't use chain rule in 2.4. But in 2.5, that's where you use chain rule. But also remember, in 2.5 you have to also use quotient rules and product rules together with chain rule, right? So what's the best way of studying for the exam? Well, I would say that you should go over section 2.5 first. Why? Because if you go over section 2.5, because it involves the product rules and chain rules and all the other rules, you pretty much, if you know how to do 2.5, you pretty much know how to handle 2.3 and 2.4. Am I making sense? Now, you have to memorize all the derivative formulas for the trig functions. You have to memorize the product rule. You have to memorize the chain rule. You have to memorize the quotient rule. The mistake that I see in the quotient rule is that when you try to find the derivative of a quotient, what's the derivative of that quotient? The derivative of the quotient is you take the square of the denominator, and then you have the denominator times the derivative of the numerator, right? Low d high minus high d low. And oftentimes people switch these two terms. So they write f of x, g prime of x first, then minus the other term. So they take the opposite. So their answer is wrong by a negative sign. It's lose 2 points. Not a big deal, but why lose 2 points just for something like this? So keep in mind that you should memorize the quotient rule and use it properly. Okay, is that clear? So these are just derivatives. So you'll be given functions, like 4 functions. F of x is blah, or y is equal to blah. Find the derivative. Okay, that was 2. And 3. 3a. You will be given a equation something like x squared plus xy plus y cubed equals to 1, and you'll be asked to find dy dx from this equation. And so this is the implicit differentiation, right? This is which section? 2.6. And what is part B? It would be find the slope of the tangent line at some given point where x is 1, say y is 0, right? When on the graph of this equation there is a point 1, 0, and at that point what's the slope of the tangent? And part C would be find the equation of the tangent at the same point. Okay, is that clear? Of course, I won't give you the same equation. The equation will be different. The point will be different. Problem number 4. You have a guess? Related grades. What do you need to do to make sure that you can do this problem? Well, make sure you do every single problem in the homework from the text. Every single homework question from the text. I think there are 6 or so problems that I assigned. If you have already done those problems, you make sure you go over them again and practice them many times so that you feel comfortable with them. If you haven't done those problems, well, you should have done it first of all. But if you haven't done it, you must do it. Make sure that you don't miss the problem. And maybe I can do one example here. This is just to do an example. Most probably I won't be asking this question. Okay, so this is let's say this is one of the homework questions. It says that if you have a cylindrical tank in that question, and this is also, I think this appeared in your web assigned problem, and we are given that the radius of the tank is 5 meter, and so this water is being filled in this cylindrical tank, and the water level, let's say, is given by this. So the water level, the height is the height of the water inside is, let's say, h. So h is the height of the water. Okay, and what we are given is that the volume of the water is, so because you are filling the tank with water, the volume of the water is increasing at a rate of 3 meter cube per second. Okay, so that means the rate of volume of water, so the volume of water, the rate of volume of water is 3 meter cube per minute. So that's the rate at which the volume is increasing. And then what you have to find is you have to find the rate at which the height of the water is increasing. So you have to find the rate of height of the water. Is the question clear? Well, as before, the answer this question, all these problems usually, like I said, three variables, right? Three variables, and the third variable is usually time. You are given the rate of one of the variables with respect to time. You have to find the rate of the other variable with respect to time. Pretty much that's what's going to go. That's what happens in most of these questions. But there are some problems you see in the homework. There might be 3 variables there might be 4 instead of just 3. Okay, but the ideas are still the same. You need to come up with an equation involving the given rates and the unknown rate. So our goal is to find an equation involving the rate of V and the rate of height, which means you have to come up with an equation involving volume and height. Okay? Am I making sense? If you want to come up with an equation involving all the rates, the given rates and the unknown rates, you have to first come up with an equation involving the variables. And well, in this case, since what is the volume of the water? Well, volume of the water would be what? Pi r squared times h, because the water is that portion is cylindrical. And the one mistake that you could make here is that you may forget that the radius is fixed here. So right away you have to plug in 5 for the radius. Otherwise you might make a mistake. So you'll be getting 25h here. And then what's the rate of V? Well, that would be the same as, I forgot pi somehow. So 25 pi times the rate of h. And from there it is pretty clear that the rate of h is 1 over 25 pi times dV dt. And because dV dt is 3, we get 3 over 25 pi. And so what's the units? Meter per minute. Yeah. This was probably one WebAssign with different numbers. Like instead of 5 meter radius, it might have been 7 or 9 or 3. Okay. Well, they wanted you to approximate that by using your calculator. Okay. Why don't you send me an email? I'll check your solution. If it is correct, I'll give you points. But in WebAssign, numerical answers, it wants it an approximate value. So if you enter something like this and if it doesn't work, it means that you might have to enter the approximate value. So I think it's probably something like point. Well, of course it's point something, but maybe 0.10 or something. Okay, so that's the related rate problems. Now, this is it. So there are 4 problems in the exam, just 4. What? It's 4 problems. There might be parts in it, but okay. So there are 4 problems. You know how many parts each one has. The first one has 2. The second one has 4. The third one has 3. The fourth one doesn't have any parts. And so, how would you study for the exam? Like I said, to make sure you get the derivative problems in problem 2. Start with 2.5, go over all the homework problems from the text on 2.5, and then go into section 2.4 and 2.3, look at only the derivative problems, right? And then you're done with problem 2. How would you make sure you can do problem number 1? Well, go to section 2.1 and 2.2, do the similar homework problems from there. How would you make sure you can do problem 3? Well, go to implicit differentiation section, practice implicit differentiation, and part B and part C are pretty easy, right? Once you know how to find dy dx, how do you find the slope? You just plug in the point, right? And then once you know the slope, you just use the point slope formula to just write it out. I mean, part B and part C are just given, like it takes a minute to do them if you know. If you have found the correct dy dx in part A. And the last, I think the most difficult one maybe for you would be the related rates problem, and so that you want to concentrate on that as well. Okay? There is an effective way of studying for the exam, and there is a bad way of studying for the exam at this point, which is, well, by this time you should have done your homework problems at least once, and when you study now, you should think about what I said today and work accordingly. Yeah.
So, like, if we were doing this related rates problem, but instead of the water level becoming higher, it was becoming lower, would it just be negative?
Well, you have to think about if the question says, for example, let's say the water is already inside, and it says that the water is being taken out at the rate of 3 meter cube per minute. That means that the volume is decreasing. So,
yeah.
if you have something decreasing, then the rate is negative. If something is increasing, then take the rate to be positive. Okay, so you're right. So if I have something taken, if you have a rate which means that something is decreasing, take negative sign. Yeah. And there might be one problem in the homework where you have to do that, I think. Yeah. Okay, any homework problems? A lot of people said at the beginning they had homework problems in mind, so go ahead and ask me those questions. Yeah. What can you tell me? Section 2.6. So this is 2.6, and problem number. So this is from WebAssign problem, right? Okay. And what's the question? 7.
7x plus y
6 plus x squared y squared, and you have to find dy dx, I assume. Okay, so that means that you have to find the derivative of both sides with respect to x. Remember, we are viewing y as a function of x. So you look at the left hand side, you have something to the power half, right? So the base 7x plus y of the left hand side, you wish that that was just x. So if you have just x to the half, what would be the derivative of the left hand side with respect to x? Well, if you differentiate with respect to x, the left hand side, you would be getting half times x to the half minus 1 if you just had x, right? However, you don't have x, you have 7x plus y. So that means that after you take the derivative, assuming it is x, you would have to multiply by the derivative of that thing that you hoped was x. And then on the right hand side, the derivative of 6 would be 0. And you would be taking the derivative of what? X squared y squared. Am I making sense? Okay, so here I am getting then half 7x plus y to the negative half. And then here I'm going to get derivative of 7x is 7, and derivative of y with respect to x, well, that's just dy dx, right? And the right hand side, you have to apply the product rule. So you have to apply the product rule here. What's the derivative of x squared? 2x, and then multiplied by y squared, plus I have x squared multiplied by the derivative of y squared, which would be what? 2y dy dx, which was easy enough. Now starts the nightmare of simplifying this or solving for dy dx. Well, what I'm going to do first is, in order to find dy dx, let's multiply both sides by 2 and multiply both sides by 7x plus y to the half. So what am I getting? Well, on the left hand side, I am going to get just 7 plus dy dx, right? So the first term on the right, it will be multiplied by a 2, so I get 4x y squared, and also it will be multiplied by 7x plus y to the half. Same thing happens with the second term. I multiply by a 2, so I'm going to get 2x squared y, and also it will be multiplied by 7x plus y to the half. And I shouldn't forget about dy dx. Is that okay? I multiplied both sides by a 2. I multiplied both sides by 7x plus y to the half. Now I have to solve for dy dx. So then whatever is the unknown, I have to gather the terms involving the unknown on the left, and gather all the other terms on the right. So the terms involving the unknowns are dy dx, and then minus 2x squared y times 7x plus y to the half, and this is equal to, and then I take the 7 on the I have 4x y squared 7x plus y to the half, and then I have to subtract 7. I forgot to write dy dx, didn't I? Okay, so I have to write dy dx, and then I have the equality here. And now I have to factor out dy dx, so I get 1 minus 2x squared y, 7x plus y to the half, dy dx is 4x y squared 7x plus y to the half minus a 7. And what's the final line? I have to say that dy dx is 4x y squared 7x plus y to the half minus 7 over 1 minus 2x squared y 7x plus y to the half. And this is it. Okay. Is everybody okay with that? Questions? Yeah.
Why is it 2x squared y instead of 4?
Did I have a 4 before? You are talking about the 2 in the denominator?
Yeah.
Well, let's go back. I have a 2 here, 2 here. When I multiplied by 2, I forgot to multiply by 2 here, right? No. Okay, so let's look at this line here, okay? Let's look at this line. And after that, I'm multiplying both sides by 2. So I get a 4xy squared. And then I should be getting a 4x squared y, right? So that's where the typo is. So I should be getting a 4 here. I think I even said I'm getting a 4, but I don't know how I overlooked that. So this is 4 here. And so this would be 4s. Is that okay? All right. So now it is okay. Any other questions? Any other questions? No? Yeah.
So just 2/9 over the 29. Just square root of each.
2/9 or 2/8?
2/8.
Okay, give me 1 second here. So this is section 2.8, number what?
29.
I have the book. I'll look it up. Okay. Okay, so you have the two sides of a triangle. Okay, so let's make a diagram here like a triangle. And let's label the sides as x and another side as y. Okay. and what we are given is that this angle here, let's call that theta, and the sides, these two sides are, these two sides are actually fixed. So one of the sides will be 4, the other one is 5 meter. Okay, and you are given that the rate of theta, is 0.06 radian per second, and it says find the rate at which the area, so let's call area by A. So the area of the triangle is denoted by A, so you have to find the rate of the area with respect to time at the moment when the angle theta is pi over 3. Let me change my diagram a little bit, because 4 and 5, they are not the same. So let me make a different triangle here. So let's say I have one side which is 4 meter, another side which is 5 meter, and I have the other side between them. And this is the angle theta, this is 4 meter, this is 5 meter. Again, how many variables do I have? I have the angle theta, I have the area A, I have the time t, 3 variables, and I have to find an equation involving the 3 variables. And let's do the following. Let's make a vertical line here. And if I have that's the vertical line, then what's the area of this triangle? What's the area of the triangle, anybody? Let's call that h. 1/2 h times what? 5, right? So this is a perpendicular to the length 5. And then what is h? Can you express h in terms of a trig function? H is the opposite of the angle theta, right? H is the opposite of the angle theta, so you know that h is what? Hypotenuse 4 times sine theta, right? Because sine theta would be h over the hypotenuse, right? So this would be sine theta, and then you have to multiply that by 5. And so the area is, what we get is basically what? 10 sine theta, right? So we got an equation involving area and sine theta. Area and theta, and then we differentiate both sides with respect to time. So dA dt would be 10 times, what's the derivative of sine theta with respect to t? Well, with respect to theta, the derivative is just cosine theta, but then you multiply by what? The rate of theta, right? Is everybody okay? You take the derivative of sine theta with respect to t, what do you get? You take the derivative with respect to theta first, and then you multiply by the rate of theta. And now you just plug in, right? What are we given? We want to know the rate of area at what moment? At the moment when theta is what? Pi over 3. So you have 10 times cosine pi over 3. And what's the rate of theta given? Is that an increasing rate? So it's positive, right? 0.06. And when you multiply them, what do you get? Cosine of pi over 3 is what? That's cosine 60 degree, which is half. So this will be 10 times half times 0.06. And what is that? It'll be 5 times 0.06, which is 0.3, right? And what would be the unit? It will be what? We are given in meters, right? So it will be meters squared, and is the time in seconds? So that's what we would get. If you have more questions on related rates, I can spend another 5-10 minutes to go over some other problems. No? Okay, if you have questions on related rate problems, you can send me the questions by email. And so when you send me an email, just take a picture of the problem and send it to me.